All right. So, for the examples of binary compounds between two metals, we writing down the formulas. Okay, I've already started with this ones. We had carbon monoxide. There we had CO, and then okay, this one is phosphorus heptabromide. So it's P, and then bromide, you know it's Br. Hepta, you should know your Greek prefixes. So hepta means 5. So therefore, this one is going to be 5 here, right? And then this one is dinitrogen tetraoxide, right? So this one is going to be N2, since well it's di, right? And then tetra means 4, so it's going to be N2O4. And then this one here, we write the names of the following, okay? So it's P2 and S5. That's phosphorus and sulfur, right? So again, you keep in mind that it ends with IDE, IDE, and we keep in mind about you take into account the Greek prefixes. So this one is P2S5, therefore it's going to be diphosphorus pentasulfide. Okay, just going to do like this. Diphosphorus pentasulfide. Remember, it ends with ide. And then this one here, you can see there's nothing, and there's also nothing, so it's a mono. But remember, for the first one, you don't use mono, so it's going to be nitrogen monoxide. And then there again we have S9 and Cl7, which is your chlorine. So this one is going to be nonasulfur heptachloride. And then this one is also the same thing. The only difference is I used phosphorus here instead of chloride. So it's also nonasulfur heptaphosphide. Right. Now this one, the second one is binary compounds between a metal and a non-metal. Now we're taking fixed oxidation numbers into account. So you need to remember that if it has an increased oxidation number, therefore is going to be the more the electronegativity, the negative the oxidation number is going to be, and less electronegativity, therefore there's going to be a positive oxidation number. And then also it ends with ide, and then no Greek prefixes. So the first example is about calcium bromide. So you have your calcium and you have your bromide. Okay, so you need to know these, your groups here. If you can see here, your calcium is no, I'm sorry. This is calcium. That was chloride. If you you look here, your calcium is in group 2, so therefore the oxidation number of it is going to be 2. And then bromide is the one that's in this line, not calcium, and bromide is in the oxidation number there is -1, right? So therefore here he said calcium is going to be +2 and bromide is -1. So this, what I'm gonna do is what I've learned in my previous years, what Dr. Quartz taught me. So I'm also gonna apply the same. So if you don't understand this, just tell me, and I don't know, I will make a way for you to understand, because what I'm going to be using is what I learned from Dr. Watson. So these two, positive 2 plus negative 1, they don't give you 0. So if that's the case, you just take this, put it here, and that will come here. So therefore, the end product will be CaBr2. There's no need for you to write a 1 here, okay? And then we have potassium phosphide. This is potassium phosphide being the phosphorus, right? And then potassium is in the first group, so it's going to be +1, and phosphorus is going to be -3, right? This one, they don't add to 0, so you just bring this one here, bring that one here. So it's going to be K3P. And then we have the last one, aluminium oxide. Aluminium oxide, so aluminium is +3, and oxygen is -2. Still, they don't add up to 0, and you just do that. Right, and then find the oxidation numbers. You're going to find oxidation numbers of the following. So for oxidation numbers, every compound must be neutral, and if oxidation number of one ion is known, then the other can be determined. So now you want that of cobalt. Yeah? This is not carbon and oxygen, it's cobalt. It's one thing, okay? So you want that of cobalt. So now we know that our chlorine is -1, right? And we have 3 of them. So we're going to see 3 into -1 is equals to -3. Therefore, our cobalt is equals to +3, because if you add the 2, they should give you 0. So therefore, the oxidation number of that is 3. Even for these ones, yeah? Since you've got this now, when you work it out, they're gonna give you 0, okay? Therefore, you'll be correct. And then for this one, you can see we have vanadium, and then we have oxygen, and we have chlorine again. So it's 3 things there. You can see that, right? So on this one, you just say we're gonna make our vanadium X, and then we know that oxygen is in the oxidation number of it is -2, so you say X plus -2 plus this one is -3, and then you say plus -3. The oxidation number of it is -1, by the way. So I said that -1 times this 3 it gave us this -3, okay? And then you say 0. So you say X -5, because if you add this 2, they're going to give you -5. It's equals to 0. Therefore, X is equals to 5. That is the oxidation number of vanadium. And then for lead and phosphorus, we have that it's 5 there, so phosphorus, we have 5 of them, so you're going to say 5. The oxidation number of phosphorus is -3 into -3 is equals to -15. Therefore, lead is equals to 15, because of if you add them, they give you 0. It makes sense, right? And then for this one,